Right, I was on mute, so that wouldn't help. Here we go. Let's start over. So, welcome to this Android 11 internals update. Good morning, good afternoon, good evening, wherever you are. So, I'm just going to do some mic checking here, and that was the first thing that I did when I noticed that I actually was on mute. So, here we are live here. This is live, and that seems to be live as well. Okay, so we have people joining us from a number of different ways. So we have a private session here where people can actually ask questions live over audio, as well as the YouTube live stream where people can comment in real time. So feel free to ask questions along the way, or if you have any comments or anything like that, feel free to post that as well. And if somebody on YouTube wants to confirm in the chat that they're receiving this good, it will at least give me some confirmation from a third party that we are all set and ready to go, assuming, of course, that you are, a few seconds behind schedule. I'm seeing here YouTube is reporting some really good connectivity, so I assume that we're all good, but in case somebody wants to give a ping, hey, I'm alive, I can hear you, that'd be awesome. Okay, so Android 11 is just out. I had a bit of fun with it, both as soon as it came out, and you can see my Twitter feed. I posted some numbers there about how much time it took me to build it and the size and that sort of stuff, so you can take a look. Yeah, okay, good. So looks like we got some people here saying that they're all good. Awesome. So I took the past few weeks to sort of delve in a bit deeper and read up on the documentation and sort of collect a few things left and right. And the slides that I've got here I'll make available to you after the presentation, probably later today or sometime tomorrow. They do have a bunch of links there along the way, so hopefully this is helpful for people to actually sort of consult what I found. Really quickly, I'll assume that most people here are a bit familiar with my background. I wrote the Embedded Linux book for O'Reilly, the Embedded Android book for O'Reilly. You can find my name in the kernel sources until they get rid of what I wrote, which will eventually happen. And when we're not helping customers, putting Android in all sorts of wacky devices, we're doing some of these presentations and having fun with the code base. Okay, so let's get into the meat of the topic here. So I'm going to start with sort of like the general flow that I usually use in my class presentations and formal presentations about this, talking about architecture, then starting to dig in various parts in more detail. Now, so effectively, one of the big pieces that's been added here, or is in the course of being added, is generic kernel image. So this is something that I'm going to spend a bit of time on here. And other things that I'm seeing here that are possibly noteworthy is Apex being sort of fully embraced and extended, and so there's more of that actually being done here. And then I'll sort of take a bunch of different things and go in different directions, and depending on the questions that we get on the chat or possibly on the private session, then I'll take some of those and delve into them in more detail. We'll see how it goes, right? Okay, the general architecture has not really changed, and I'll assume that you've seen some of my other presentations before. Effectively, this is the same architecture diagram that I've been carrying over and over and over. I did slight changes to it here just to reflect the reality of 11, namely the fact that you've got these vendor hooks in the kernel that are now available. So this is sort of something that's specific to GKI, the Generic Kernel Image, and I'll explain to the sort of reason for this when I get to that a bit later on. Otherwise, bits and pieces of here and there stuff that have been added. Otherwise, most of the architecture has pretty much remained the same. You'll have to forgive me here for a second. I have to take care of one administrative task. I will be with you in a second just to make sure that we're all, set and ready and going good here with everything. So give me 1 second. So. All right, good, done. All right, so generic kernel image, as I said, this is one of the big pieces. This is kind of like the central thing. If you want to kind of if you want one takeaway from this entire session, that should be it. So generic kernel image is a pretty big sort of departure from the way things were done for the kernel in the past. And so I encourage you to spend some time exploring this one in a lot more detail if you haven't already heard about it or seen any documentation about it in the past. So to explain the relevance of GKI, let's first take a look at how things have traditionally been done in Android, essentially how things have been done since the beginning. Android is downstream from the Linux kernel developers, all right? And effectively, this is what you see here. So the Linux kernel is released. The Android takes a version of this and then effectively sort of cooks up its own thing with the additions they have to make. This is then taken by the silicon vendors, which create a BSP. The BSP is then taken by the device manufacturers to create devices. This is a diagram coming from Google, so it talks about phones. Then this is actually certified by the carriers and goes on to the actual users at the end of it. So this essentially remains the same, except in the very early days of Android, there was no requirement necessarily in terms of what kernel versions people could or could not use, right? So essentially, you could grab any kernel so long as it ran the Android open source project, you were good, you're okay. You could actually get away with whatever it is that you're doing. So the problem is, of course, that devices were shipping with end-of-life kernels. So these are kernels that were obsolete by definition, had security issues, and effectively users would buy devices with known sort of CVEs active on them already. And so even though the user might not have sort of seen the value of this, it did actually have an impact. And everybody in the ecosystem was sort of like always worried about this, including the kernel developers themselves, who were kind of like worried to see devices shipping in so many units with kernels that were not so up to date, right? And of course, even within the same silicon vendors, you sometimes had inconsistencies. So when Treble came along, and that was in 8.x a couple of years back, one of the things that was done here is to formalize a bit of this. So sort of try to see what could be done at a very basic level to make sure that there's a bit of consistency here. So one of the very first things that Treble does is effectively require the use of long-term support kernels. And the LTS kernels, if you're not familiar with them, are maintained at kernel.org by Greg Kroll-Hartman and other folks. And effectively, the deal with that is they will take a specific kernel version and then will maintain it over a few years. Traditionally, LTS kernels, which I think were first put in place around 2005 or so, those kernels would be supported for about 2 years. So in other words, they take one of them, like here, for example, 419, they freeze it and then sort of continue maintaining it for 2 years, and that meant that they were backporting important fixes into those, including security fixes and so on and so forth. Because Google mandated LTS kernels, it meant that downstream from them, so that meant effectively, from downstream from Google, which is this Android common kernel that you see here, the silicon vendors would then actually provide OEMs with actual kernels that will also LTS. So what's the benefit of this? Well, in theory, the benefit, of course, is that you can effectively sort of short circuit every party here in the middle, if you're an OEM, and then sort of go with a newer LTS and then patch over or apply the patches that were given to you and then get yourself a fresh, kernel for whatever period of time that this was maintained, okay? So that was already a good thing. I mean, having that is already much better than we had before, because now we can effectively sort of take the silicon vendor and the sort of Google out of the equation to an extent and say, go with a newer LTS with our kernels. All right, cool, nice. But still, there were issues with this. So what Generic Kernel Image is trying to do is something like this. And so forgive me for the very basic diagram. Some of these are made by Google, so they have fancy sort of artists, I guess, making those. I'm a bit more, Inkscape kind of person, and I doodle these very basic diagrams. So the early stages is still the same. So Android or Google is taking kernels from kernel.org. But now what Google is doing, or what it is providing, is something called, or moving forward at least, is something called Generic Kernel Image. Okay, this is my generic kernel image here. So Google puts this out, and the idea is that all devices are supposed to be running GKI. All right, so it doesn't matter, which silicon vendor you are working with. The assumption is you're getting a GKI from Google. So how does the silicon vendor actually do its job? Well, the way it works then is effectively the silicon vendor takes also GKI, but then creates modules on top of GKI, which they give you, and you take GKI and these silicon vendors as modules, and then off you go, you ship a product. All right. How is that beneficial? What's the added value here? Well, the added value here is effectively once you've shipped the product, the silicon vendor is completely out of the equation, and Google's going to be able to continue shipping these GKIs, moving forward, and then effectively the devices will get updates, which is, from my perspective, truly awesome, because Google has a good track record of, moving along the updates, and they have a dedicated kernel team that's doing a fantastic job. So from that perspective, the fact that we now depend sort of on Google for the kernel images, or moving forward will depend on Google. You see why I'm sort of putting conditionals here in my speech in a second. It is great. All right, this is a very good benefit for everybody in the ecosystem. How is achieved when all vendor BSPs are modularized? So I'm not sure what you mean by KPI here. If you want to sort of just elaborate on this in the question, I'll pick that up. I'm happy to pick this up, but I'm not sure I understand what you mean by PI. Sorry. Okay, so that's the goal. All right, this is the goal. To achieve this goal, all right, there's a few things that we have to cover. So first of all, there's the Android common kernel. Now, this is not something new. It's been existed all the time for a long time. The idea there, boot time. Okay, yes, sorry. So give me a second about boot time here. I'll get back to it. But yes, it's certainly, something that the Android developers have had to contend with. And yeah, I know what KPI generally means, but I just wanted to understand it in the context of this of the question that's here. So okay, makes sense for in terms of boot time. So yeah, I know. So effectively, you've got the Android common kernel that's been around for a long time, and the Android common kernel is a version of the kernel that Google grabs from the kernel developers, and they add to it the additions that are needed to run the latest versions of Android. So the change that's been made around 2019 is effectively the fact that you've got now they're tracking mainline. So effectively, what that means is that whenever on a daily basis, as Linus puts out kernels, then effectively what they do is they update their Android mainline as well. All right, so that's kept up to date all the time. And whenever a new LTS version comes out, whenever a new LTS candidate comes out for use in Android, they grab that LTS from their own mainline, since they're tracking Linus, and then they sort of freeze it off to a certain version of Android. So you can see here this one being frozen for 11, and then from 12 will start off with that, but they'll also grab another one for 12 somewhere down the line in 2021, as you can see the date here, and then go off with this, right? So this is important. The fact that they now are tracking sort of mainline in real time is a good thing. And it makes it such that, whenever an LTS kernel comes out, they no longer have to sort of spend a lot of time trying to bake into that new LTS the Android features that they need. All right, they're there on an ongoing basis. Okay, and sometimes I get the question, so who are they? Usually when I'm talking about Android and that's the Android team. Will phones going to QR upgrade use older kernel or newer generic kernel? I can't say. I can't answer that question. It depends, I guess, on the manufacturer that you're working with. So one thing about GKI kernel releases is they are based on this new model with Android mainline. So in other words, this in the kernel common that they have, which they have a mainline branch, that the GKI kernels will be issued against this. Okay. And so whenever for the, they decide that at a certain point, if you can see here, for example, selected 5x selected 1220s. So in other words, sometime in December, they're going to take one of these kernels and they're going to say, okay, this is the one that we're using for the upcoming 12, all right? And at some point, they're going to say, okay, that's it. We're feature complete. The kernel sort of features that we want, we know them. We're good with this as it is right now. And now we are going to freeze that, and then this is going to become GKI. And this is the term frozen here. You'll see that actually sort of being used in a few ways because the generic kernel image needs to provide a uniform or consistent API to the modules that are going to be provided by the vendors. So in other words, a vendor which now has to do board enablement based on modules has to talk to an API that is sort of maintained somewhere. And that's called the kernel module interface. And I'll get back to that in a second. So the frozen tree that you see here says the KMI interface is now frozen. We know what it is, and we're sticking to this. So like kernel continuous integration. I guess so. I mean, you will certainly have some CI stuff in here for sure. But in terms of the KMI stuff, there is certainly some testing that's going to be done on this on an ongoing basis to make sure that the KMI, the kernel module interface, is sort of preserved and stable. Okay, which gets me to talk to you about KMI in a bit more detail and the sort of architecture they have in mind, or that they're actually rolling out, not just in mind, but that is actually being rolled out, and what that means for sort of vendors in general. So the green stuff effectively, as you see, is AOSP. So in other words, this is provided by Google. So Google provides, and sort of, they don't show it on this diagram, but this is like the kernel space, and this is user space, all right? So assume here the horizontal dividing line here is my kernel versus user space. From or mainline, you mean GKI kernel will be distributed by Google as part of a partner module. So it means a kernel is closed source in Android. Let me get back to that a bit later. So the idea is, yes, Google is providing GKI, but based on this sort of some article I was reading on Ars Technica, it doesn't seem that they're going to push the sort of providers to sort of push this off to their customers directly necessarily, right? Hold on to that for a second. But let's just say that GKI is not necessarily closed source. It just means that Google becomes the custodian of the images that get published, all right? It's then off to the vendors to take those and then create the modules that are needed to make their hardware work on it. So you're going to have a GKI module, so I guess those are additions that Google makes, and then you get the KMI, and this is important because this is effectively the kernel module interface. This is effectively the surface against which that the silicon vendors as well as OEMs are going to code their modules so that they actually provide whatever the functionality that they need to provide, right? And I have an additional diagram that I got from one of their presentations coming next that gives a bit more detail about this. But the short story is the vendor modules are added against this KMI or coded against this KMI, and they will provide whatever they need to provide here for the HAL implementations to actually work on top of all of this, right? So the HALs up there will work both with the GKI modules that Google provides and the ones that the vendor provides. However, it remains that the generic kernel image is something that Google is the party that issues out. Slide 5, after version frozen, there are still arrows patches being applied. Yes, so for the previous slide here, I guess somebody was going back, I guess this one here, I assume, effectively, yes, there are some additions being made here for the cherry picking some patches, and here as well, sort of, this 5 here, not page 5. Okay, I was confused. Sorry, this. Yes, there's a bit of cherry picking going on here from the actual sort of, versions, whatever they are. But still, at the end of the day, it's Google that is the custodian of this. Right, so I see questions are coming in fast, so I'll sort of, what I'll do is I'll take them when there's a good segue for me to pick them up. I won't stop for every question since they're coming in a bit fast. Okay, so this is the overall picture that you've got here. And you can see here, this is unstable interfaces. So in other words, against internally, there might be some modules that are being that are using some internal APIs, but the KMI interface itself is going to be stable across Android platform releases, as you can see here, right? So whenever you provide modules for a given version of Android, they ought to work with that kernel for the entire set of releases. What about device trees? Yes, so they use device tree overlays. That's the mechanism that's supposed to be used here to sort of provide functionality for the vendor editions. Will DT be provided by vendor or Google? Yeah, no, so there is going to be device tree overlays. That's the mechanism that's going to be used here for actually sort of making that kernel sort of and the vendor modules work with your hardware, because of course every board is different, and so if there's no way to sort of say, hey, here's my hardware, how would you actually go about doing that? Okay, so a bit more sort of information about KMI. So what they do is they export symbols. So for those of you who are familiar with kernel development, you've got these export symbol macro that's being used to sort of expose functions. And what they do is they use that to define effectively this KMI, all right? And then the vendor implementation uses those exported symbols for the purpose of providing whatever functionality that has to be provided, okay? So those are kept stable, and that's important. They have actually, you can look at Matthias Manik's presentation from Linux Plumbers. They also have some tool suites for checking the actual sort of conformance of this KMI, or sort of its continued working over time, so that it actually doesn't sort of break the ABI along the way as you go from one thing to the next. Okay, so that is for the KMI interface. And so in 11, right, this is what they consider sort of version 1.0 of the deployment of this. The idea in 11 is that you're supposed to use GKI for conformance, for compliance testing, and effectively this is not, however, required to ship your product. So in other words, the idea is you're going to have vendor modules and use those with your product kernel if you want, right? But for certification, you're going to run GSI, which is the generic system image. For those of you who don't remember this is effectively the image of the system partition that Google puts out that is required for actually certifying your device for compliance. You're going to have to run GSI against GKI with your vendor product, with your modules, and then effectively you can replace the kernel still. You don't have to ship with GKI, all right? So in 11, you actually can still continue shipping with your own kernel, but with the same sort of interface that they've defined here. What about optimization of GKI kernel? Is it possible from size, point of view, performance, boot time, or will it release with a set of drivers? So the optimization of the kernel here at this point is, of course, left to Google, since they take ownership of this. And I guess this is sort of like a way to say, okay, you know what? We're going to reparent the problems of everybody that we have as our own problems. And if you have sort of effectively, performance issues at boot time, they're everybody's problem to the entire Android ecosystem. And so then the performance hits that you might have would be sort of isolated in the modules that you have, all right? Okay, re-asking, is KMI versioned like stable AIDLs? Oh, I'm sorry, I missed that question earlier. Yeah, so is KMI versioned like stable AIDLs? To an extent, yes. I think that's my understanding of that interface, is that effectively you are sort of, once you're in the family of a given release, that stays stable within that family of releases. So just give me 1 second here. I think I have a question here from the private session. Still required for ARM64 5.4 for R. Yes, so that's right. So in my understanding is GKI is for ARM64 with 5.4 for 11, right? That might be different from other sort of devices, but from my perspective, the one they speak of is ARM64, at least publicly. Okay, are kernel modules updatable via Play Store in 11? Not that I know of. So what you will see is they seem to, and then this is my upcoming slide here, effectively for the Pixel devices, they seem to actually want to sort of push the actual releases off using Apex files. I think I have a link later on to some sort of commit they have in the tree that shows what they're doing with that, and that's kind of interesting. So that means effectively you would get a kernel, off of Play Store for your device, at least for the Pixel devices, and that would be fascinating to see. Okay, what about kernel config? Is it tweakable? Is the kernel configuration tweakable? Not to my understanding. So again, anything that you need in addition to what Google has by default in GKI is something that you're supposed to provide as a vendor module. All right. Since effectively Google is the official publisher of those GKI kernels. Now, bear in mind one thing. I mean, they are sort of moving into this understanding that there are complexities, to the whole scheme. So, from reading, some of the interviews that they've given, reading their documentation based on the conversations I've had with some of the folks, my understanding is they're sort of charting this as they go. They are setting goals for sure. I mean, the goal is ultimately to have all these devices running GKI. Still, they, I guess, will make adjustments in due time depending on what comes back from partner ecosystems. But they have actually sort of already worked on this with close partners. So if you go to the Linux Plumbers Conference proceedings from this year, which we held a few weeks back, there was a presentation as part of the Android Micro Conference about the experiences in the ecosystem with GKI. So it's not like this is sort of brand new for the silicon vendors. They've seen this coming. Google's been talking about it for a long time. And so the general consensus was that this is a good direction to go to, but it might take a lot of time to get there. And I think they're slowly getting to that stage. Okay, so from slide 7, it's not clear if CTS tests are added and will be run for GKI verification. So my understanding from this layout they have is that this is actually also required. So in other words, you're going to run CTS over GSI over GKI with your modules, right? That's my understanding from what I'm seeing. KO module signing will be removed. I don't know. That's a question I have no question for. I have no answer, sorry. I don't have the answer to that question. Okay, so so starting from 12, the idea is to make it so that all devices are shipping with GKI. And sort of this is consistent with the sort of rollout that Google has done in the past for new features in Android. Like remember when they introduced the SE Linux or SE Android stuff, initially they started as permissive, and then later they set it as enforcing. And so this is sort of the sort of thing that we see constantly with Android. Is in this case they're saying, okay, going to make you walk before you sort of run. And in this specific case, that's what we're seeing in 12. They're going to push it all the way out to effectively, in 12 taking ownership of the entire thing and releasing it. So the idea there is that you can then sort of update the boot partition, which contains your kernel, without actually touching the vendor partition, which contains the vendor modules, which are then sort of coded against KMI, which is supposed to be a surface that is constant and therefore should just continue working out of the box for everybody. All right. So based on what I was reading, as I said, I think Google seems to be wanting to push their Pixel updates, kernel updates via Apex. That's going to be interesting to see. And really, at the end of it, really, I think the bonus, the greatest benefit here is for OEMs, at least, for a lot of folks that we work with, one of their sort of, problems is always, okay, I shipped a product, it's in the field, I want kernel updates, I'm not getting in from the silicon vendor, what do I do? And so this sort of takes the silicon vendors out of the equation, and certainly is cause for celebration, all right? So not that I dislike the silicon vendors. I have very good friends that work at some of those places, fantastic people, but it's just the incentives of the ecosystem were not properly sort of set up. And I think that by sort of taking ownership of the actual sort of kernel that sort of aligns the incentives and in due time might actually help with upstreaming, because at the end of the day, the silicon vendors are going to want to put as little effort as possible into those modules and maintaining those modules. So maybe there's going to be an incentive to actually push back stuff into mainline. We'll see. Apex overlays boot. How does it replace boot image partition? I mean, Apex overlays system. Yeah. So how does? Okay. So a question here from the private crowd. How does Apex sort of allow us to update the boot image, since Apex conceptually is originally meant for actually overlaying the system partition? Hang on to that question. I'll try to show you the actual sort of patch they have or addition they have in mainline for that, how they generate the Apex that actually does this. And in fact, what they really do is they have a shell script really that actually just goes and flashes the kernel image. So that's really what they do. Okay, one thing that sort of came out in the Linux Plumbers Conference that sort of was very interesting to me was this concept of vendor hooks. Let me just catch this question here. Wants to sell chips, not create BSPs. Yes, absolutely. Very good point. The silicon vendors want to sell chips. They're not in the business of creating BSPs. If they can, wash their hands of this, they're very happy. And totally understandable. I mean, not faulting them, but just saying the incentives in the ecosystem were not sort of lined up. How the init startup sequence change after having vendor boot image. So I do have a later sort of section when I want to talk about init in more detail. So maybe I can. I'm not sure when we get to that if we're going to be able to see that, but hopefully, I'll be able to point you in the right places there to see what you're looking for. The idea there is that you have a new partition called vendor boot, which is available very early on in the boot process, where we load those vendor modules from. Okay, right. Back to the vendor hooks. So during the presentation, I think it was by Todd Kios at Linux Plumbers, there was apparently sort of a passing mention of this. I was actually emceeing the whole 4 hours, but since I'm emceeing, I'm not listening, I'm just emceeing, and so therefore, sometimes stuff just, passes off the top of my head. So anyway, later on in the BOF, which is also recorded and available on YouTube, by the way, both sessions are available on YouTube. Effectively, Todd mentioned this again, and then I sort of dug in and I asked, so what is this? Can you please explain a bit more? And so the idea here, and I think it touches on a lot of the questions that we had here, vendors sometimes OEMs need to sort of dig in and get their hands dirty with some things in the kernel for all sorts of reasons, be it performance, be it, specific product requirements and so on. And so how do you do that if, as some people were sort of asking in the chat there, Google now closes this off, so we can't sort of, change the kernel anymore. What the heck, right? I need to go in there, change this or that in the scheduler. And so this is something that's not in the documentation. At least the documents apparently are not yet public for some reason, whatever. But the code is there. And so these hooks that they've added, let me kind of show you here. Open this up. So. Okay, so add support for vendor kernel hooks, add support for hooks, include trace, blah, blah, blah. So it's based on trace points, that's the first thing. So it's a mechanism effectively where they instrument a whole bunch of things in the kernel to allow them to then actually sort of allow people to go in and hook into different parts of the kernel over KMI and say, okay, you know what, I need to grab this. I need to do something different here than what would actually happen. So register trace name, blah, 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 declare hook. So you can see when I put the links up there, you can actually see sort of the detail of that, and you can see the hooks they have here that are listed. So actually this is, let me actually just go to the main line. So let's go to main line here. Let's go to see what they have today in there. So let's go to include. Let's go to trace and hooks. So you can see this is actually a new directory for this. So this is the hook definition here. And so you can see they have a whole bunch of hooks that are being sort of added. So CPU idle hooks, scheduler hooks. So there's a whole bunch of things in the schedule that are being hooked. And so presumably as a vendor, you can go in there and use those hooks to sort of do things differently from what Google would have done in the GKI kernel that they provide you. Okay, so let me just try to catch up here. How this I took are the mechanisms to software update, ensure vendor boot, and vendor images are synchronized. I guess that's left to the vendor. What is the impact on bootloader added by SOC? Is it also covered by GKR? Is bootloader deprecated? No, so the bootloader is still there. Effectively, the bootloader is really just left still to the sort of control of the silicon vendor and the actual OEM, and to do whatever it is that they want with those. So I don't see anything right now that changes this. There was actually a whole session about that at the Linux Plumbers Conference. Very interesting conversations there. So we'll see. Maybe in the future there's some sort of standardization on bootloaders, but that's not there yet. Let's go back to IBM. Yes, IBM mainframe OSs. Back in the day when I was doing Linux tracing, I was interfacing with the RAS team at IBM, who had this thing called dprobes, which allowed them to sort of hook into the kernel anywhere and sort of instrument stuff and get information and so on. This is sort of the same sort of family of ideas. But this is the interesting thing here, for me at least, is that they are sort of taking the stance that, okay, we understand that we are taking ownership of this and this is going to cause trouble for some people. So we're going to give you a way to sort of hook into this and sort of change things that are there by default. All right. So maybe in the future they have some more formal information about it. I just found the sort of change sets and I put them in the slides. Again, the slides will be available later, so you're happy to just to go in there and have a look at see what's in there for you. Okay, partition reworking. So every version that comes out, at least recently, they've been tweaking the partitions a bit. They added product at some point. They added ODM. Now they're adding this thing called System X. So the vendor partition or the vendor boot partition is yet another thing that they have in here. So so the idea behind product, which this is not new, product is not actually new from 11, but the idea behind product is to say, you know what, you can have a single system image across multiple SKUs, and then you can customize the SKU itself by having custom product image, right? The System X is effectively a way to sort of package your extensions to the system partition. So the system partition classically contains the core of the framework. So if you go back to my very first diagram there, let me just go back here really quickly. So if I go back here, framework really is kind of like the core here or system, sorry, is not just the core, but really also some stock packages up there. So there's a whole bunch of stuff here that comes from system, maybe not the Heidels, but kind of all this stuff here is sort of found in system. And the question is, how do you customize this? Given that system is one partition that Google sort of wants to more or less be the controlling party of it. They haven't sort of yet, and as far as I know, walled it out and said nobody can change system. But I guess they're moving in that direction by saying, okay, you know what, the vendors that want to extend the system core functionalities ought to use System X for this. And I like the diagram or the table they have here, which I grabbed also from source.enra.com. So this shows you, for example, at the Java API level, what things you can call if you're running in one of these partitions versus another, right? So if you're running in System X, all the sort of APIs are available to you. If you're running on a product, the hidden APIs aren't available to you, and neither are the vendor sort of partition code. And if you're running on data, then your regular application. So presumably you can only access a regular API. So all of these things that I'm moving on quickly here through, you can actually get the details of them by going to the actual documentation on source.enra.com, and the links are sort of spread out in the slides. You can take a look at that later on. Virtual AB is something that caught my eye. They do say outright that this is an early design and therefore all design details or requirements are subject to change. The equal there at the end is a typo, sorry. So anyway, so the idea behind this is to say right now we have two update mechanisms. One of them is a recovery-based mechanism, the other one is an AB-based mechanism. And the idea behind virtual AB is to say, okay, let's just have uniformity here if we can, right? And so to work, this uses actually the DM snapshot capability. So DM stands for device mapper. It's a kernel functionality that sort of interleaves a layer between sort of the file system types and the actual block layer to sort of add all sorts of functionality. So full disk encryption is there, DM Verity is there, and all sorts of other things of that fashion. And the idea behind virtual AB is to say, okay, we understand that not everybody's got the space to sort of have AB partitions, but yet they would benefit from the rollback capabilities. So DM Snapshot allows you to sort of take an original device, as you can see here, create a snapshot of it, and then effectively, if you read and write to that, what you're really doing is just writing deltas into a copy on write sort of space. And also the DM's snapshots or snapshotted original image is still accessible, except what the original things are sort of also sort of backed up in the copy on write. So this allows us to sort of have a soft AB to a certain extent. Again, they say this is subject to change, so we'll see how it goes. But I think it's an interesting concept. Looks like hooks are the answer to your vendor. That's right. I need to move image headers. Yes, so actually, thank you, Amit, for answering questions. So if you don't know Amit, he's one of the guys at Lenaro, super awesome guys, and Amit's an awesome dude. Been happily, interacting with him for the past almost 10 years since we met in India a long time ago. All right, so this is the virtual AB functionality, right? Which gets me to talk to you about Apex. So Apex is not new to 11. Apex has been around since, and let me just see how we're doing on time here. Okay, we're still good. So Apex has been around since 10, and if you saw my last presentation about Android internals, the 10 update that I did about a year ago, I had mentioned I had some reservations about this. I still do to an extent. But hey, again, maybe this is the road to travel. Maybe it's the right way to do things. So the idea behind Apex is to say, okay, you know what? System is, the granularity of the update of system is too, hard to work with. We need something that's a bit more nimble. So the idea behind Apex is to say, okay, we're going to replace a few things in system, not on OTA boundaries, but rather in a more granular fashion using Google Play, right? So then you take parts of the stack and you say, okay, assuming I'm Google here, I go talk to my vendors. Hey, any of you guys really need to customize this? I mean, is there any value for any of you guys to customize this? I don't think so. None of you guys disagree? Cool. Let's make this an actual Apex module. And so Google then takes ownership of the updates of this for the vendors and then starts making those available over Google Play. So the key here is that you're looking at parts of the system image which are generally speaking non-differentiating. I mean, there's no value added by the vendors of sort of customizing art or customizing the time zone data or that sort of business. So then Google sort of creates a Apex image with that, and then it is able to roll them out on the devices without sort of having to go through a full OTA. So the idea, I think, is great. The execution of it, I think, as I said, I had some reservations about it. So the way it works, for those of you who haven't seen my other presentation, is an Apex file actually is an APK, right? It's just an APK file with a bunch of additional things inside of it. Namely, it has a payload image. So this is actually a file system image that is actually signed and DM Verity'd. So this is actually one of the reasons of this of proceeding with this sort of architecture, because the Apex, because it's got a file system image, allows Google to continue using DM Verity to check payloads and therefore ensure that the payload is properly signed and therefore the content of it is legit. All right. So you've got here effectively in the payload a whole bunch of pieces that may be sort of updatable or replaced, like binary images, like libraries, like jar files. These are examples, of course, again coming from Google's website. All right. And so this is sort of sometimes referred to as being part of the project mainline, at least in term. This is apparently the sort of project name as it was announced at Google I/O. As somebody that's done kernel development in the past, when you say mainline, for me it means something completely different. So every time I hit this name, I'm kind of confused. What do you mean mainline? But then I have to sort of twist my head here and try to refer back to the fact that that it is something that refers to a Google project about modularizing the system contents. Anyway, I digress. So coming back to the Apex stuff. So yeah, this is what I mentioned here. Once it's verified, it's actually loopback mounted. And let me actually show this to you here. So let's go to this. All right, let me actually just change sort of the profile so you can actually see this a bit better. So let's make sure we've got this, and lunch, I think it's 31. So lunch is a bit slower in 11 than in 10. I presume it's because of the way they actually do the lunch selection now. It used to be much faster than this. I haven't investigated exactly why it's actually slower here. Can you share a slide presentation after the end? Yes, absolutely. The slides will be available later on. So let's go over for the emulator. No cache. All right, so unable to connect to EDB daemon. Really? Okay, so if I go under Apex, and let me just, for making it easier, easier to read for me at least. All right. So if I go under Apex here, what you've got is a whole bunch of directories. And so the content of these directories that you see here are actually all coming from those file system images. And if you do mount like this, if you type mount to see what's mounted, you'll see here that it's got all these Apex stuff here that is mounted on loopback. So those are the images that are actually mounted on loopback and then verified with the DM Verity business and all the rest of the stuff. Okay, so the idea here is you can roll back Apexes. I think this is one of the interesting features of this is effectively if you roll out an Apex and has got a problem, you can say, you know what, I already had a version on this device that worked, this new version doesn't work, I'll roll back to the older one. And then they just do a sort of soft reboot to sort of go back to this. And so this is what I was mentioning here. They have, let's open this up here. If I go off to master, and I'm changing, sorry, give me 1 second. I'm having a problem with my mouse. So totally unrelated to what we're doing. This. All right, if you're the maintainer of this driver, please fix it. Anyway, so my laptop, when it comes back from suspend, the scrolling doesn't work. So I was saying that, you know, they've got the GKA update on as an Apex. And if you go taking a look at how they actually update this, how they actually update the kernel. So this is what they do here. They got this script. Checks if there's a payload, applying payload. And the apply payload here that you see is actually a command line tool. So there's a command line tool called update engine stable client, which gets the payload. I assume the payload here is actually sort of a kernel image, and then takes the kernel image and then, you know, flashes it onto the actual boot partition or whatever else, right? Okay, so this is for Apex basics. Now, there now are a lot more Apexes in 11 than there were in 10, all right? And you can see that really easily, you know, when you go into the command line and you sort of compare stuff, and I'll show you what I found in a second. So, right, so there are still some things that I'm unclear about. Maybe the answers are there, I just don't know them. If you do know the answer, hey, by all means, please share either here in the chat or in the comments later on in the video if you watch it later on. So you know, how do OEMs use this? Do they do side loading? Do they have an alternate store? That business is not clear to me. And so, or you know, could we have sort of a vendor Apex, or is it just Apex and then vendor or something? I don't know. All right. And the really big question I have, which sort of tails into my presentation from last year, is will this scale? I mean, okay, we've got maybe 2 dozen entries now. Are we going to get into the hundreds? You know, from my perspective, the question is when does the AOSP sort of generate actual packages for me to do a pseudo APT update, pseudo APT upgrade sort of thing, right? Could we possibly have a system that in the AOSP generates Debian packages or RPMs or whatever novel way they find That would be nice, all right? But that's maybe misguided on my part. There are a lot of things that the Endo team has to handle, given the number of hundreds of millions of devices they're working with, that I'm not privy to. So maybe this is the better choice. We'll see. So some additional packages, and my numbering sort of walks off the stage at this point and is broken. Anyway, slide needs fixing. So those are solely additional Apex packages that I spotted by going into the actual sort of system and just looking under Apex and comparing it to version 10. Right, so ADB is now an actual Apex. You've got stuff like cell broadcast, which is sort of unifying a lot of cell handling. You've got here neural network stuff, and I put the links here where I found an equivalent sort of documentation on source.ado.com. So again, those are usually things which are non-differentiating. This is the key here with the Apex packages. One thing that I was really surprised is to actually see the VNDK actually becoming an Apex. That sort of wasn't in their documentation, and I only saw it on the device, and kind of led me to question whether what I'm supposed to read into that is that somehow they discovered that VNDK API surfaces needed to be sort of fixed over time, or something like that. I'm not sure. But they sort of moved the VNDK, and maybe it's just totally benign. Maybe it's just because they want to be able to continue sort of doing security updates on those VNDKs. I'm not sure. Are bootloaders aware of Apex updates causing bricks? So there are actually rollback mechanisms. If you read the Ars Technica article that was made, I believe the gentleman's name is Ron Amadio, but I'm not sure. There was an interview by Ars Technica, one of the journalists at Ars Technica, a couple of weeks back, in September, I believe, with Dave Burke and Ilyan Malchev from the Endo team. And they sort of mentioned that there's a lot of engineering effort into sort of in those fail-safes. In other words, making sure that if a device goes awry because of an update, whatever it is, Apex or otherwise, that there's a way to sort of come back on their feet with that thing. Okay, as part of, and so here's the numbering, also the slides kind of being broken for some reason. The idea is that when you do an Apex update, traditionally what they do is they do a full reboot of the system. And so in this case, they've added something called soft restarts, in which case they do sort of like a shutdown of the user space, sort of kind of like a stop zygote, start zygote, if you've ever done that. And they try to bring the system back on its feet without sort of going for a full reboot from bootloader to kernel to user space and all the rest of the stuff. Yeah, especially GKIs are updated on the fly. Yeah, sure. There needs to be some sort of safeguard for sure. So if you want to take a look at that, have a look at this documentation link that I've got here. Ultimately, they say that if they fail in the actual soft update, they do a hard reboot to sort of come back from it. Okay, and for some reason, I think I know what's going on here. Let me just go back to my slides. Where is that? For some reason, numbers are good. Fixed it. Okay, one thing that I was made aware of a couple of weeks back when I was talking to a customer of ours is that that was before even the release of 11. That effectively seemed to be documentation about a move from HIDLs to AIDLs. And I was like kind of surprised, like, what, are you sure? I think of the other way around. HIDLs have versions, HIDLs have all these features that AIDLs don't have. Why would you move from HIDL to AIDL? And I really would have loved to be the fly on the wall in that meeting there where this was decided, because it seems that this is sort of the classic discussion of, hey, this protocol doesn't work, let's add a new protocol, and all of a sudden you just have one more thing to sort of maintain. So the idea behind moving the hardware support from HIDLs to AIDLs is to just have one unique mechanism. I think it's a worthy goal. I think it's an interesting sort of thing to want to sort of cut down on the number of interfaces and number of abstractions that you create. This is interesting as a goal in and of itself. All right. I have some reservations about this, as I'll mention in the next slide, but there are some interesting things that seem to be sort of highlighted in the description of it. I have not played with this enough to be able to sort of confirm whether this is true or not, but the idea, it seems, that is that it's going to be easier sort of to create a fork of a Heidel definition or HAL definition and then create your own custom thing instead of sort of reparenting and changing the other stuff. One thing is for sure is that they are still keeping the old Heidels as they are. It's not like they went into hardware interfaces and changed everything. And so let me show you around here. If you go, let me actually open sort of something like this. Let's open Emacs. Let's go to hardware. Let's go to interfaces. And if you go look in here, like for example, under, I don't know, graphics composer, and you look under these things, it's still still got HAL files. I mean, they haven't gotten rid of the HAL files. But every so often, if you go, for example, under power, they have 10, 11, 12, 13, and it seems instead of doing a 14, they added the AIDL interface for it. So AIDL fixed all the issues it caused them to create Heidel. Also the version of Heidel libraries in VNDK. Right. I guess maybe I don't fully understand, you know, the value of it, or haven't yet sort of perceived the entire value of it inside yet. But you know, certainly, you know, what seems to be the case is they kept the Heidels as is, and they're moving slowly to the AIDL stuff, right? So things that I don't like is effectively, you know, that in AIDL you have to declare the types. You have to have one file per type that you need to have. That for me just bloats the entire directory. I really like the fact of having a types.hal, but that's just my personal opinion. The other thing is the major versus minor numbers. I did like the major and minor number sort of thing. Now effectively the major numbers are going to be something like this, you know, Bluetooth 2, right? And so I you know, personally, I don't like this. Maybe it's just change reluctance, right? Or maybe I just don't know enough about it. So I'll have to play around with this. The other thing is that Heidel had support for generate statements that return multiple values. So I don't know, AIDL doesn't do that, at least as far as I know. So I don't know, maybe something to be added to AIDL. Okay, ADB. So if you've done any sort of platform work, ADB is something that you're using on a daily basis. So knowing what's new in ADB is cool, all right? So they added two main things to ADB. One of them is secure Wi-Fi pairing. So in other words, being able to sort of ADB connect over into a device that's operating on Wi-Fi, and also some compression options. And you can see here sort of like the rundown of what the new options when you type ADB and what's gone away. So this backup restore thing's actually gone from the help. And you can see they now have compression options for push, pull, and sync, and they have this pair option for pairing with the device over TCP/IP. And the idea is that if you look at their sort of interface for settings now, which I think I have a link for somewhere in here. Yeah, here it is. Let me open this up. So, oops, did not work. Open this up here. So yeah, they have effectively, if you go under the developer options, you want to, wireless device. So you enable the wireless debugging option, and effectively it asks you whether you want to allow it or not. And then effectively you get yourself a sort of a pairing code. And this pairing code is actually a key for an AES-128 sort of link between the two devices. So when you type ADB pair on one device with the IP in the port, you're going to be asked to enter the actual sort of code that was given here. And then you're then paired, and you can actually connect to the device. So why that? Why not just allow the use of the traditional ADB TCP or TCP/IP in order to set up the interface? Well, the problem with that one is that it is a bit fragile in terms of security, because you're then opening the port for anybody on that network, not just sort of a secure communication. In fact, I had found one forum post on OnePlus by, it seems to be one of the folks working on OnePlus, that said, we disabled this because it's not secure, so we're not trusting this TCP/IP thing anymore. All right. So the code base seems to say that it's AES-128. I kind of overkilled this one, and I went and I grabbed all the commits that were involved in the addition of that. If you want to have a look there in the slides, you can just walk down the list of things that they've added here for making this possible. It's interesting because so the settings application actually now has an interface in the ADB system service to sort of do the queries for those for like configuring the pairing capability. It would have been interesting to have this because I mean we work with a lot of customers that are using Android and things which may not actually be a phone and may not even have Wi-Fi, but they may have network connectivity. So it'd be interesting to see if this could be extended to other network capabilities. Just sort of a random, okay, here's sort of like a secure key that is going to be known on the device or sent to the device in some sort of out of band fashion, and then a way to communicate with it sort of remotely. Right now it's just it's Wi-Fi based. So the compression is just sort of basic sort of compressing the data being transferred over, and it seems that based on the commit message, this gives them a 2x performance benefit. But it seems that on USB 3 there's some slight sort of slowdown here, as you can see in the actual comment that's here. Oops. So the results slightly dropped pushed, presumably because we're compressing and extracting on a single thread, but the gains overload binary transport make it worth. There you go. All right, let's talk about additions to the hardware abstraction layers. So they did add a few hardware abstraction layers. So you can see policy under audio. Automotive now has a CAN bus. Occupant awareness and surround view, which I'm planning to investigate at some point. CAN bus is what you think it is. It's just the CAN bus. I haven't spent a lot of time actually investigating those new HALs in detail. So those are certainly on my homework list of things to go and investigate. All right. There are no sort of removals usually in that directory. So that's a good thing. If I can show you here, actually, I have a sort of extended view on this somewhere, not in this shell, I believe in the other shell. Where's that one? This one right here. So if I do something like this, meld of hardware types. No, not this one, actually. I want to compare two of them. So give me 1 second, actually, go back to here. So let's go for meld of hardware types clean with media, blah, blah, blah. And then this internals, hardware types, hardware. If I type it right, it'll work. Bingo. All right, so you can see that there's a lot of versions that have been added though. I mean, in addition to new HALs, there's quite a few different new versions that have been added for different existing HALs. So Keymaster, you got here. So Power, which now has an AIDL, radio at 1.5, et cetera, et cetera, et cetera. So if your area of expertise is one of those things, then have a look at this directory in more detail. Some of the new HALs are Heidel, others are stable AIDL. That's right. Yes, correct. That's indeed it. So effectively, you've got here. You've got some of the new Heidels are added as Heidels, classic Heidels, whereas new ones are AIDL'd. Again, something that I want to spend some time a bit more investigating. Okay, let's take a look at the AOSP. So what is it that we have in the AOSP that's changed? There's a tremendous amount of stuff, so I'm going to try to go through this a bit quickly here, especially since we've been into this in an hour, and I usually plan those for an hour and a half or so. So maybe we overflow a little bit, but anyway, let's see what we have. So in terms of lunch targets, there are new lunch targets. Quite a bunch of these, for car. It seems they added car capabilities or sort of added the ability to use some boards or some configurations as also car targets. This sort of should simplify or help simplify the life of people working in the car business, because the one thing that's been lacking in the past is actually a number of targets to actually play around for car targets. For building Android 11, is Ubuntu still recommended? And can you confirm on build time change between Q and R? So I built it on 18, so I don't think you need 14. And in terms of build times, I in my past presentation, I actually had some stats. I forgot to add them here. 10 takes about, so this is a 6-core Xeon with 32 gigs of RAM. Sorry. And it takes about an hour and, 3 hours and a half to build 10. It takes 4 hours and a half to build 11, sorry. When, 4.5 is something I can still sort of tolerate, but maybe I'm going to be due for, if I, do this for a couple of months, maybe at some point I'm going to want to update. We'll see what happens. All right, so lunch targets have been added, more lunch targets being added, including DB845, which is, I think, the Dragon board, which we'll also see later on in the list of things that are added under devices. Removed. So Marlin's been removed. In fact, it's actually removed from the actual tree itself. So I think this is the Pixel XL or something like that. So if you take a look at HMM, so this is a useful command to sort of get shortcuts. I do this diff to see what's been added. So there's a go grep for grepping Go files, own grep for grepping the owners. Nothing substantial. I've also noticed that there's something called trigger build, underscore trigger build in the sort of list of stuff at the end there. I don't know what that is. I have to look this up. Okay, if you take a look at build core, so usually looking into there gives you an idea of the things they support, the new things they support, or what they changed or whatever else. So just a random list, which one of which caught my eye, or a few. Rust, and you'll see this Rust thing actually a bit later in a second. So right, so this is Rust, removed, Android VTS, blah, nothing super substantial. The devices being added, as you can see here, Google Car has a whole bunch of entries in there. So again, a whole bunch of targets for being able to run Android on car-like function, car-like hardware. Dragon board, so this is the 845 and added by the Lenaro team. Actually, kudos to the Lenaro team. I've been looking forward to getting back a sort of a Qualcomm-based device for AOSP development in AOSP itself, and so this is good to have in there. Marlin, as I said, Pixel XL seems to have gone the way of the dodo. All right, if you look at external, there's a whole, this one changes a lot, and so I haven't seen anything here that caught my eye too much. If there's something in there that you see in this list that's of relevance to you, or that you have a question about, or that that you're like super happy to see here, please let me know and why you think it's great. I don't, I mean, except for ATF, okay, Android Trusted Firmware. The one that I sort of caught my eye actually is down here, a bit further down. This. So I'm not sure what they intend to do with that. I'm not sure what that means. Are they intending of having some Rust code in AOSP, or is this just because there was some module they added in external that needed Rust? Big question mark. I don't know. Stuff that's been removed, one of them that sort of caught my eye was the perf stuff. So you see your perf data converter removed, and there's a bit more some perf stuff that's been removed. It looks like they sort of dropping a lot of perf functionality there, which is the performance analysis tool, command line tool in Android. Frameworks, just subtle things there. Under system incremental delivery, so this presumably has to do with incremental FS stuff they've added. There's a presentation about the incremental stuff at Linux Plumbers by Paul Lawrence, I believe. So if this is of interest to you, then have a look at this. Are there any changes with regards to SE policies in 11? I have not had the chance to do a comparison on this, so I don't know. They usually are sort of gradually adding stuff over and over, from time to time. Okay, right. Extras, nothing here except again the perf stuff sort of going sort of away, or I'm not sure what that means. The fact that they're getting rid of some of the perf things. Okay. So, native Android user space. So what's changed when you shell into the device and you sort of look around? What do we see that is new or that is different? So the first thing is init. So let me actually show you the difference between the two inits. Let me actually close this one here. Let's go open meld again. And let's go for, I believe here, it's init system hw init.rc. And then the other one is a different directory. So let's go for init rc files, init.rc. Okay, so a bunch of imports that are being changed here. So you can see here, for example, that they're moving a lot of things under system etc init HW instead of just being flat out at the top, and you'll see that actually at the top level of the tree itself. What else is here that we've got? Set our limits at notify, generic linker config based on Apex in Bootstrap namespace. So early init property. Okay, I'm not seeing anything here that's super talking to me right now. Create stune. Mount binderfs. So binderfs is interesting. Is an interesting thing to see here because I'm sorry, I'm trying to circle with my mouse. There we go. Okay, so they got rid of debugfs, which is something that's later on in my slides. So debugfs, which was sort of one of the debugging interfaces of the kernel, is now verboten in 11. You can't ship with that because it's not consistent. It's, you know, it can have security issues and whatever. So they got rid of the debugfs stuff. However, debugfs did contain things that were provided by the binder driver as information, and so they created this binderfs to actually sort of make this accessible. Okay, binderfs again, user bypass. What else do we have in here? Freezer C group. So the the freezer thing is to allow to suspend processes. Wait clock stuff. What else? I'm going fast here, just because the file is pretty kind of big here. So I just want to make sure I spot anything that sort of speaks to me directly. For those of you not familiar with this, sometimes you see this in some files. This is sort of the internal bug tracker at Google. I'm always frustrated when I see those because, like, damn, I want to see what's underneath here, please. But you don't have access to those. At least as far as I know, you don't actually have access to those. It'd be nice to be able to know what those are. If you know a way how to get those, please let me know. I'd love to see how we can actually get access to those things. Okay, so allow Apex-D to be snapshotted. And I noticed that I actually forgot to do something for the folks watching me over the private stream there to allow them to see my screen in a better resolution. I apologize for this. Lesson learned. Okay, start Zygote. What else do we have in here? Properties. On user space reboot. Yeah, this here seems to be the last bit that you see in this init RC file seems to be what's required for the soft reboots, which I mentioned. So, okay. So this is effectively the sort of soft reboot capability, I think, as seen in the actual init RC file. Okay, excuse me for getting from the topic a bit. How will these change affect automotive AOSP and OEMs in terms of vehicle HALs? A short explanation will be highly appreciated. What do I see these changes changing in terms of automotive use cases? I think this is, for the most part, it's mostly evolutionary, just additional, HIDLs, additional functionalities. The big change, of course, is GKI. So I don't think that there's any sort of difference, in terms of what was already known in the automotive business before for Android. It's just a continuation of the same business as before, with additional HIDLs, namely the CAN bus, the surround view, and the occupant awareness HIDLs, which are new. Otherwise, whatever you were doing in development in automotive, I think, at least for the folks that we've been talking to in the automotive space, I don't think it changes much to what they've been doing in the past. It just adds on top of it. Okay, so that's for init. Yeah, if you take a look at what's inside the RC file, so those files that are added, files that are removed, that sort of business. Global properties, again, I could do the same business. I can bore you with this, ad nauseum, with the sort of the global properties. Get prop. No, not here, but rather this one here. So get prop clean versus the other get prop. And you'll notice that some of these actually have to do with the new partitions. That was at least the thing that I sort of glanced by comparing them. Not here, but rather get prop. Right, so writable, boring SSL, init, SVC service debug. Those are the ability to debug the services themselves, which I think I have a sort of section about this in my slides last year. Boot time, boring SSL, boot time. Where is the partition stuff here? Product, build, product name, product system extension. So these actually have to do with the new partitions that have been added, and some more stuff like that. So the properties vary also greatly from one to the next. The mounts, the biggest change that you'll see in the mount is debugfs. So if I actually, or at least it's not big in terms of size, it's big in terms of what it means. So if you do a comparison of the mounts here, and so I had a bit of fun here, sort of creating myself a bunch of scripts that actually go fetch a whole bunch of things across the AOSP, both at runtime and in the sources, to sort of allow me to glance at what's going on. So you'll notice here that effectively debugfs is gone, all right? So all the debugfs stuff is just, it's not mounted anymore. If you look at the other files, there's of course a lot more apexes, so of course a lot of mounts for apexes itself. You've got binderfs, which I mentioned earlier. A dev freezer is from the control group mechanism, and yeah, a whole bunch of other things that get mounted here. So doing a sort of comparison like diffs between those things is sometimes interesting. I could do the same thing here for the process list, for the system service list, and so on and so forth. There's a whole bunch of stuff to be looked at. Okay, at the root of the file system, let me just catch up on the questions here. Considering the elimination of perf resources, does this imply the capability is removed, or is it possibly replaced? Okay, so my understanding is that it is replaced with the BPF stuff, all right? So effectively, it seems to me that what they have is the BPF capabilities are replacing the perf stuff, but this is just an educated guess based on my reading of things. Any change to display graphics? I think there's some new titles there that you might need to look at, but I haven't sort of investigated, for example, the capabilities of the Surface Flanger or any of the other related things to see what changes were made there. I presume they are, right? Okay, removed, right, all the init star stuff is gone. All the RC files are gone from top level. You've now got systemx as a top level directory. This is the new partition, which I mentioned earlier, so it's consistent to actually have that here as well. Right, we can, okay, I could diff those, again, there's tons of stuff here that you might spend time looking at, but one thing I do want to show you is, so if I look at that, I don't think there's much to be sort of appreciated looking at system itself. So I think system itself has remained mostly consistent. So system, root system clean. So that here, except for systemx, forget about this. This is a hack I did. So systemx is the only new thing that's in here. System bin actually, though, brought some interesting things that I was kind of like, made me kind of question what's going on. So if you look here at clean, okay, this system bin, comparing the other system bin, right, root system. What am I doing wrong? Yeah, it is here. Okay, so I'm not sure why I was not finding it. Let's just do that. Right, root system bin. Okay, so if you compare those two, and that's not going to work, is it? This. What? All right. Bingo. So some stuff actually went, where is it? Down here. This. So modprobe, for example, went from toybox to toolbox. I don't know what that means. I'm curious as to what this is. I want to go take a look at this in more detail. So toolbox is the legacy or sort of built-in shell replacement that Android has, whereas toybox is the package maintained by Rob Landley, which is brought into the AOSP. And a while ago, they had moved most stuff to toybox. So I'm kind of surprised to see stuff going back to toolbox. I'm not sure why they need to do that. This is interesting. So I need to look at this in more detail. And the same I think I saw somewhere else. Here, set prop is now also being reverted to toolbox. Start and stop are being reverted to toolbox. Of course, there's additional stuff here that you can see by just glancing at the output. Right, and so that's sort of, oh, one thing I sort of completely forgot to put in my slides for some reason, I'm not sure why I did that, but anyway, is the system services. That's always a key thing to do, and so for some reason it was an oversight on my part. So let me just bring this up and just show you a comparison. So if you do a comparison of the system services, as usual, of course, they added a whole bunch of system services. So some of these are things that require a bit more investigation. For example, one of them I went down the list here and I looked at this app integrity thing, and I spent about an hour looking at it. And it seems to be some internal functionality that's required for some proprietary things they have. So this is sort of like talking to the package manager, or when a package manager is installing an APK, goes and calls into this and asks it to check for its integrity. But there's like it's just an engine. It's not actually checking the integrity. So there's sort of a pluggable engine mechanism, and then I guess the engine is coming from somewhere else, which I presume is some Google Mobile Service proprietary application or something like that. But I don't know. So some of these, of course, are in and of themselves, worthy of investigation further down, to actually see what's exactly being added here in terms of system services. Right, and so the BugFS I already mentioned, so effectively is gone, and the bullet points that you've got here really are taken straight from source.android.com. So this is effectively the arguments that are being made by Google for removing debugFS. I can't say that it's that big of a loss, but it is sort of like an interesting surface for kernel investigation. So maybe enable it during development, but effectively, since it's Google's going to take care of GKI, then presumably they will not enable this. And for the rest of the stuff, I have no idea what they're actually doing with that. And beyond this, and this is something I also didn't mention here, but I sort of presume people know about this. Maybe I shouldn't. If you go to source.android.com, this is the developer android.com. I want to go to their source.android.com. So let's just get rid of that here. Let's go to let's do this. Okay, source.android.com. So if you go here into the release notes, they actually have sort of like the full release notes of everything that's new in 11. It's a lot of information, but they do have a lot of the pointers there. I find this useful as a guide, as a starting point, but it's certainly not, for me, sufficient to understand what's going on in internals. I usually have to go in, build myself one of those systems, run it, see what's going on and how that's different from previous systems. And as I said, I have a whole bunch of scripts that I run to sort of grab information from two versions and then be able to compare them side by side to see exactly what's going on, right? So yeah, that's pretty much it really on my side. And the developer website also has something similar where they sort of have the developer sort of, new stuff that's been published as well for application developers. So that's it for me. If you have any pending questions, we'll stick around here for a few minutes to catch any questions on YouTube chat or elsewhere. And if I exhaust all questions, we'll just sign off and, hope to see you guys again in some other future video. Right, gotta give a chance here for the folks watching on YouTube, since it's always a bit delayed there with the playback. It's about 40 seconds to a minute and a half, depending on what you've got in terms of delay. All right. Well, effectively, again, if you want to sort of remember the most important things that were added in 11 that you certainly should take a look at. So GKI certainly brings its own set of complexities, but I think simplifies a lot of things for a lot of people. I think this is going to be a benefit to the entire ecosystem moving forward. I, for one, welcome the fact that I'll be able to sort of get my updates from Google for the kernels, and then effectively, the modules, the hardware enablement still has to come from the silicon vendor. That's great, but at least we have something that we can sort of depend on Google directly from. Other things that are interesting is, of course, the continued and expanded use of Apex. We'll see how that sort of goes on over time. And then sort of the general sort of additions here and there that are expected to happen from one AOSP to the next. Hopefully, what I've presented to you here has given you some way to sort of start looking at the things that you might actually be interested in more detail. Okay, yeah. So thank you all for participating. I'm seeing some questions here. Let me just catch those up. Maybe you could add some slides. Unstable EIDLs. There's some cool stuff done with hash files. I will take a look at that. So certainly, I have not had the chance to fully investigate this AIDL business, moving from HIDLs to AIDLs. So hopefully, maybe I'm just misreading it, and it's the right thing to do. I'll take a look at that in more detail. Our support for tablets deprecated. I don't think there's a sort of deprecation of that thing. It's just, I think the market is just changed a bit, and where there was a lot of enthusiasm in the beginning for such things, I'm not sure there is as much enthusiasm these days. The SE Linux question, as I mentioned earlier, so there probably are. I just haven't investigated those. The stack is huge. As I tell people usually, I don't claim to know everything. I just have a general good sense of where things are, and I, have been in the stack long enough that I sort of generally know what to look for across versions. This sort of exercise in any version of Android that I've gotten my hands on, it, for me at least, it remains sort of a yearly, exercise where as I continue using the new version, I sort of learn more and more about it. Over time. This has been true for the past 10 years, and I don't expect it to change anytime soon. Is VB Meta still in scope? Yes, VB Meta I think is still there, and they do have some things their comments about that in their updated documentation. Removing handle will have more overhead on dev binder. No, actually the removal of, so the transition from AIDL to HIDL, from HIDL to AIDL doesn't actually remove binder from the equation. It's just that effectively the definition language, the interface definition language, goes from being HIDL to AIDL, right? Okay, so that will be it. Thank you all for attending. If you do watch this video later on YouTube and you spot any errors or have any suggestions, please feel free to add so in the comments. We'll try to pick those up when they come. And of course, I'm an eager learner, so if you have anything to share, by all means, feel free to do so, either online or directly to me or whatever else. All right, thanks again, and take care.